tax per $1,000 of a taxable value of a home. For a certain county, the millage rate is $28 in tax per $1,000 of taxable value of the home. A city within the county also imposes a flat fee of $112 per home. The proper tax, T of X in dollars, for a home with a taxable value of X thousand dollars is thus given by T of X equals 28X plus 112. We want to find T inverse of X. So first we replace T of X with Y. So Y equals 28X plus 112. Then we interchange X and Y. So X equals 28Y plus 112. Now we solve for Y. So X minus 112 equals 28Y. Y equals X over 28 minus 4. So T inverse of X is X divided by 28 minus 4. Okay, now we want to evaluate T inverse of 2,996. So T inverse of 2,996 is 2,996 divided by 28 minus 4, which works out to be 103. And then what does this mean? This means a home with property tax of $2,996 has a taxable value of $103,000. And that's it. Okay, next we have Jerome wants to invest $35,000 as part of a retirement plan. If he invests the money at 1.4% annual interest rate compounded continuously for 50 years, what will be the balance in his investment account at the end of that time? And what will be the total amount of interest earned by the investment? Round each answer to the nearest cent. And here I've given you the formula, A equals P times E to the RT. So plugging this in, I have A equals 35,000 times E to the 0.014 times 50, which is 35,000 times E to the 0.7, which comes out to be $70,481.34. Okay, next it's just using your calculator. Key in the common log of 15, and I would say keep it to at least 4 decimal places. 1.1761, and this one would be 2.7081. That's all I need for that. Hit your common log button, 15, enter, and natural log button, 15, enter, and give me 4 decimal places. Okay, so here we give you a great big hint. Using a graphing calculator, solve the equation. Approximate the solutions to 4 decimal places. Note, we're looking for where it equals 0. So when I plug this equation, y equals 2x minus e to the 2x plus 2 into my calculator, I get a graph that looks something like this. So as you see, there are 2 zeros. Now I just find them. I hit second trace, 0. Left bound would be somewhere here, right bound would be here, and that will give me negative 0.9207. And my second one, left bound would be here, right bound would be here, and that comes out to be 0.5731. That's all it takes. Okay, now we're going to write the expression as a sum or difference of logarithms. So let's break this down. We have the log base 3 of 3 plus the log base 3 of x to the fifth plus the log base 3 of y to the third plus the log base 3 of z. Okay, this is 1. This becomes 5 times the log base 3 of x plus, and this becomes 3 times the log base 3 of y. And there's nothing more we can do to the last one, so log base 3 of z. That's what I'm looking for. Okay, solve the equation. Write the solution set with exact solutions. Round your solution to 3 decimal places. So I can translate this. Remember, this is the log base e of t minus 5 equals 2. So this is e squared equals t minus 5. So e squared plus 5 equals t. And then key that into your calculator. You get t equals 12.389. Determine if this function is 1-to-1. Well, the easiest way to do it is to graph it. So let's find a few points. If x is 0, f of x would be 1. If x is 1, f of x would be 4. If x is -1, f of x would be -2. Looking at my graph, -1, -2, 0, 1, 1, 4. Well, as you probably can see from there, this is a line, and it's not a horizontal or vertical line. So, yes, it is 1, 2, 1. Okay, what about this? Well, again, if we have to, let's plug it in. X is 0, y is -4, x is 2, y is 0, x is -2, y is 0. Is it 1-to-1? No, not 1, 2, 1. It's a parabola. Okay, next step. Now we're putting it together. Solve the equation. So I have plus here, so that's the same as taking the log base 2 of x times x plus 6 equals 4. So the log base 2 of x squared plus 6 equals 4. Which means that 2 to the 4th equals x squared plus 6. 2 to the 4th is 16. That's plus 6x. Equals x squared plus 6x. So now I have x squared plus 6x minus 16 equals 0, which is x plus 8 times x minus 2 equals 0. So x equals -8 or x equals 2. I cannot have a log of a negative number, so it is simply x equals 2. Okay, let's skip number 9 for now and go to number 10. Now, number 10, you could do this by trial and error. 4 to the first is 4. 4 to the second is 16. 4 to the eighth is 64. Not eighth, third. 4 to the fourth is 256. 4 to the fifth is 1024. And 4 to the sixth is 496. So x equals 6. There you go. Okay, going back to number 9. Actually, there's two ways we can do this. Isn't 4 simply 2 squared? So wouldn't 4 to the 2x minus 1 be 2 squared to the 2x minus 1? Or 2 to the 4x minus 2? So I can rewrite this as 2 to the 2x plus 2 equals 2 to the 4x minus 2. Now, since I have the same base, the exponents are equal. 2x plus 2 equals 4x minus 2. Subtracting 2x, I have 2x. Adding 2, I have 4. So x equals 2. You can even check your answers. 2 times 2 is 4 plus 2 is 6. So this would be 2 to the 6th. This would be 4 to the 4 minus 1, or 4 to the third. So this is 64. 2 to the 6th, 2, 4, 8, 16, 32 is 64 as well. So our answer is correct. For 9 and 10, I will probably show you a different method in class. So that's it for this one. Have a good day.